Hello everyone, in this video I am going to talk about mechanism of Baeyer-Villiger oxidation. Actually this is a very simple reaction. So normally we have ketone or aldehyde sometime. We can convert this ketone to ester using this kind of peroxide. So this is very simple reaction. So for this kind of peroxide, so generally people use this MCPBA. So this is we call metachloroperoxybenzoic acid, metachloroperoxybenzoic acid. So this is actually general structure. Metachloro, okay, chlorine in meta position, this is the structure for MCPBA. Or sometimes you can use hydrogen peroxide also for this peroxide, and then we can convert to this ketone to ester. So general mechanism for this this kind of reaction. So mechanism, so we can draw like this. So first of all we have ketone. So this ketone react with this peroxide. So we have hydrogen. You need to always draw a lone pair, okay, remember those. So this is a peroxide. So this peroxide, so we have lone pair here. This ketone attack to this hydrogen in peroxide and then create this anion. So and then we have this anion. This one. Okay, so this anion now attack to this electrophilic carbon. So we have electrophilic carbon here and then break this bond, and then we have this one. Okay, OH now here, and then R2 here, and then we have this so this one. Okay, this intermediate. So you always need to draw, remember this lone pair. Okay, and then now what happened? So now we have this here we have lone pair here. So okay, sorry, I draw more lone pair here. Actually, you should only two. This lone pair directly trap this hydrogen and then break this bond. Actually here we have actually you need to draw like this. It's better to draw like this hydrogen like this, and then this lone pair attack to this hydrogen, grab this hydrogen and break this bond, and then make double bond with here, and then this you have this carbon bond in this R2 and this carbon, and then that one break and then go this make new bond here. Okay, understand that. And then we have new another bond, this oxygen bond break and then create new bond, and then this bond also break, and then actually we have, remember that, okay, it's very more arrow in this step. So and then actually we have this ester R1, this ester like this. Okay, so and also we have this carboxylic acid. So you see here we have double bond, oxygen oxygen double bond, right? So that double bond here, this one, and then we have OH bond here, this one actually, and then R. So that is the byproduct, carboxylic acid and ester. So we can isolate actually these two because it's the more and very polar carboxylic acid and also non-polar ester. Very easily we can isolate. So maybe you wonder, so this oxygen always actually come from this ketone, so it didn't change because this is the ketone oxygen, and this oxygen actually come from peroxide. So that is actually this oxygen. Okay, so and R2 we had in our previous ketone. So remember, it's very only this step actually will be complicated. So when you push arrow, so that's the step you need to make sure, but other arrows actually very easily you can push the other arrows. It's not complicated as you see. Okay, so I hope you understand the mechanism of this Baeyer-Villiger reaction oxidation. So it's very simple mechanism. So in the Baeyer-Villiger reaction oxidation, so you see when we have ketone, we can convert this ketone to ester using peroxide. So that's the general reaction. So I hope you enjoy the video, and I will see you in another video. Thank you very much.